Thank you for joining us today. My name is Chris Sensor with Data Physics, and today we're going to talk about the channel table setup and sensor calibration. This is building on previous seminars that we've done. We are recording, and the recording will be made available after the seminar is over. As a note here, our next seminar is going to be on the 24th, and it's going to be about setting up a single shaker random test. And then following that, we also have one scheduled for October 8th. As I mentioned before, this is building on previous seminars that we've done. So we're going to jump right in. You can see the videos on YouTube, our Data Physics YouTube channel. So please check out previous videos to see how we get to this step. So jumping right in, this is our channel table. First thing to talk about is the Edit Systems button. If you have multiple systems that are connected to the PC, you can add them through the system selector here, and then what you'll get is a column of what the combined system is capable of. In this case, 44 channels, 3 output channels, and 1 tach. And if I hit OK here, it'll populate the channel table with all the available channels in that combined system. Of course, today we're only going to be using a single 901, so I'll take these back out, and it is that simple. Next thing to mention, I'm going to start over here and start working backwards. Engineering units is where you can set up custom engineering units and or look at the entire list of units that we have available as default. To add a unit, all you have to do is click on Add User Unit here, and this will come up. An example is I had a customer that wanted to display nanovolts instead of volts. So it was very simple. I copied the SI units from volts here and just added a scaling factor, e to the -9, and that got me to nanovolts. Next, if you have a channel table already set up from a previous test, you can actually pull that right in. For example here, oh, that's the one I'm in. Let me pick one at random here. Here we go. So you can see this modified the channel table to one from that previous test. Next thing to talk about, we're going to skip back over here. There's radio buttons here, and this little inputs button. This is actually a button itself. So if you click here, this is going to show you how the system that you have selected is configured, and you can enable and disable channels just by clicking on the GUI here. And that will affect the checkboxes here. The radio buttons sort into different configurations for the columns in your channel table. So you can see when I have all, this is all the possible columns. A lot of these aren't used for every test. For example, point and point increment is typically for modal hammer impact tests. Shaft angle, obviously for rotating machinery. Point and direction for geometry, again for modal tests. So we filter these out. Front end is pretty much the basic items that you need to be able to set up accelerometers and other sensors in your test. So for instance, this first channel I have just connected to a source. So I will set the coupling to AC single-ended. Auto range I'll keep off. I'll set the range to 3 volts, and let's say 800 millivolts per volt. Just as an example, we're going to do sensor calibration later and see how this value changes. Another feature that we have here is this sensor class, manual, obviously type in manually, but we also support TEDS, which stands for Transducer Electronic Data Sheet. And we also support what we have as a sensor database. So if you have some sensors pre-programmed in here, you can just select the serial number and it'll populate all the unit values back at the table here. To get to the sensor database, we click on the sensor button, go to sensor database, and as you can see, there's a whole plethora of sensors here. If I want to edit a value, it's that simple. If I want to read in one of my TED sensors, I just hit the Read TEDs button, and that'll pull in and put in the serial number and what the sensitivity of that accelerometer is. Back over here, auto range function is a function that basically takes a measurement of where you are in this range that's preset. If you have it off, it'll do nothing, but if you set it to up or up down, it will change the range either up or up and down to accommodate what it's seeing in a kind of pre-test situation where you might do some basic excitation and see what the range of incoming values is on your sensor. Range is the range of the ADC that can be set to 0.1, 0.3, 1, 3, 10, and 30 volts. And this is the range in engineering units, which is linked to the range in volts. So as you can see, if I change my range in engineering units, it's going to change my range in volts. If I change my range in volts, it's going to change my range in engineering units. Millivolts per engineering unit column is the sensitivity of the sensor. This is typically coming in a calibration sheet, and we also have a feature where you can calibrate those sensors directly, and we'll take a look at that in just a minute. Offset allows you to move basically the zero value of your y-axis, basically putting a DC offset or taking a DC offset out of the incoming signal. Sensor class we discussed, and serial number and label are bookkeeping things. On to the other radio buttons. Info is filtered out for basically modal information. Comment is just label and comments that you can fill in. And then we have these user selections here where you can right click and click on column chooser, and then you can create your own user defined filtered list of columns for your particular test needs. For instance, sometimes I like to have the same settings as front end and have, in addition to that, the name. And then I can type in a name that shows up during my test. So I can set that up as a user sorted set of columns. Some of the other areas up here to talk about is math. This is where you can set up signal and channel math in the software. We will cover this in more detail in another session. There's a lot of things that you can possibly do with channel and signal math. It's a pretty neat feature. Outputs is where we would set what is coming out of the source. In a analyzer type test like this one, we can do things like, let's say, burst random for a modal shaker test. We set a level and width of the output block. In the front end section of this, you can set the range and some other things. In particular, you can actually set a input channel to link to the output so that you can play out the output from an input. Some neat things there. And again, we have these user columns As you can see, if I click all, there's a whole plethora of things that we can do. But just to show an example of what I mean with this channel assignment, I can pull in from a recording and map that out to an output channel. Moving on to generators. Generators is where you can create a custom signal to output through the DAC. All kinds of different interesting things that you can do here. Again, this kind of warrants its own seminar, and tach channels as well. This is where you can set up an incoming tach channel if you're doing a rotating machinery measurement, and we'll cover this in more detail when we do a rotating machinery session. The last thing I wanted to cover in detail today is our sensor calibration. This is a pretty neat feature of the software. There's a whole calibration panel. For right now, I have my source right into an input channel. I'm just going to calibrate on voltage. The sine generator can be enabled, but typically what happens is you'll have a handheld calibrator or a piston phone for microphones where you would input a level in Gs or dB for a piston phone. But today I'm just going to output a signal from our DAC and feed it back in. We have this multi-sensor capability if you want to calibrate all the sensors. If you have a special calibrator that can calibrate all the sensors at once, that's what multi-sensor does. And we also have this checkbox that will output a report of the changes, and we'll see how this works now. So once I get all of this information in here and how many averages I want to take, and there's a couple different modes here, I'm going to pick auto. That's going to zoom right in on what it's seeing as the peak here. I'll hit initialize. And calibrate. And now we're going to output this sine signal at 100 Hertz with 1 volt peak signal. You'll see our software zooms right in and starts taking a couple averages and tells me, oh yeah, of course, 1 volt is 1,000 millivolts per volt. So we're going to change your sensitivity here, and it's going to prompt me to say, hey, do you think this is right? And I am going to hit yes. And it'll change this, and now I can move on to do another sensor, or I can come up and hit save. And I want to write my change calibration values to the test, and it will spit out my report of the calibration that I did and the change that it made. That is all I have for you today. Again, please join us for our next seminar on the 24th for setting up a single shaker random test. If you do have any questions, please feel free to email me directly, chris.sensor@dataphysics.com, or visit us on the web at dataphysics.com. Thank you for your time and have a great weekend.